In our first problem, we're going to convert 5.4% to both a fraction and a decimal. To change it to a decimal, it's easy. You just take the decimal point and move it 2 places to the left and complete missing spots with zeros, and then get rid of the percent symbol. So we have 0.054 or 54 thousandths as our decimal. And because we have 3 decimal places, that is 1,000. So we're going to write 54 over 1,000. 54 thousandths, 54 over 1,000. And then let's reduce that to lowest terms. These are both even, so we can divide by 2. So we get 27 over 500. That's going to be our fraction. So again, to change 5.4% to decimal, just move the decimal 2 places to the left, get rid of the percent symbol, and then because we had 3 places after to the right of the decimal, that's the thousandths place, so we put the fraction over 1,000 and reduced it to 27/500ths. Now to change 27 thousandths to a percentage, we're going to move the decimal 2 places to the right and add a percent symbol. Now we're going to find 5% of $297. The first thing we're going to do is change that percent to a decimal, so let's move that 2 places to the left. Tack in the 0, so we're going to have 500ths, 0.05, 500ths. The word of in algebra means times, multiply. So we're going to multiply the 500ths times 297. And now we use the calculator. And that's going to give us $14.85. We're going to use the distance equals rate times time formula to find the value of the missing variable. So d equals rt, distance equals rate times time. And we're given that the distance is 750 miles and that the time is 2 days. So we're going to substitute for d and for t. And that gives us 750 equals r times 2. And now we need to isolate the rate, so we're going to divide by 2 days. And 750 divided by 2 says that the rate is going to be 375 miles per day. So you're going to want to remember to tack in your units. So the rate is 375 miles each day, per day. In our next problem, we're going to find the area of a triangle with a 4 centimeter base and a 5 centimeter height. Now you may recall that the formula for the area of a triangle is A equals 1/2 the base times the height. Area equals 1/2 the base times the height. So we're going to substitute in the 4 centimeters for the base and the 5 centimeters for the height right into the formula. And because we can multiply these 3 numbers in any order, I'm going to go ahead and multiply the 4 times 5 first. That's going to give me 20, and I know that 1/2 times 20, or half of 20, is 10, and our units are square centimeters. So 10 square centimeters. In this problem, we're going to find the circumference and the area of the circle, and we want the answers both in exact form and rounded to the nearest hundredth. And you can see that our circle has a diameter of 6 inches, which means that the radius is 3 inches. To find circumference, circumference is equal to pi times the diameter. So for the exact form, we just substitute in 6 where the diameter is, so circumference is 6 pi inches. And for the decimal form, just use your calculator and use 3.14 or use your pi key and multiply 6 times pi. And that's going to give us 18.84 inches. For the area of the circle, we use the formula area equals pi times radius squared, pi r squared. So we're going to go ahead and substitute in our 3 for radius. So area equals pi times 9, 3 squared. And that's, of course, square inches for area. And so for our exact form, we just write 9 pi square inches. For our decimal form, we use our calculator and the pi key, and we get 28.26 square inches. Now we're going to find the measures of the angles in a triangle when we know they're x, 2x, and x plus 12. Find the value of x. And since we know that the measures of the 3 angles in a triangle add up to 180 degrees, this is going to give us our equation. So we're going to add x plus the 2x plus the x plus 12, and that equals 180. And now here on the left, we're going to combine the like terms. So that gives us 4x plus 12 equals 180. And now we're going to solve for x, so we're going to subtract 12 from both sides. So on the right we have 168, and that equals 4x. And dividing by 4, we get x equals 42 degrees. In the next problem, we're solving the formula for perimeter. Perimeter equals twice the length plus twice the width, 2L plus 2W, and we're going to solve that for the variable W. So we first have to move over the 2L term, and we're going to do that by subtracting from both sides. Now on the left-hand side, this P and this 2L, they're not like terms, so you're just going to write P minus 2L on the left. That equals to 2W. And since we're solving for W and want it by itself, we're going to divide both sides by the coefficient 2, by this 2. Now, when I do this division here, just a word of caution, you cannot reduce those 2's on the left-hand side because of the P being there with the L. So just leave your answer P minus 2L over 2. Now we have this area formula. Area equals 1/2 H times A plus B, and we're solving for A. This 1/2 H, that's the same thing as writing H over 2. So I'm going to do that first because you're going to see that it's easier to move this H over 2 that's multiplied times the parentheses if we just multiply both sides by the reciprocal of that. Flip it. And so that's going to be 2 over H. And you do that to both sides. And of course that A is like an A over 1. So I'm just going to put 2A over H. Notice how multiplying by the reciprocal cancels these two on the right. So we have A plus B equals 2A plus H. 2A over H. And so now we just subtract B from both sides. And just a word of caution, notice that we have a capital A and a small lowercase a. These are two different variables, so they're not like terms. So now we have that 2A over H minus B is equal to little a. And that solves our problem. we have the linear inequality 3 minus 2x is greater than 11 plus x. And we're going to solve for x, so we're going to get these x's on the left side of the inequality sign. So we're going to subtract x from both sides. So we have 3 minus 3x is greater than 11. Now we're going to isolate the x, so we'll subtract this 3 from both sides. So negative 3x is greater than 8. And now to get that x isolated on the left, we're going to have to divide both sides by a negative 3. But remember that with an inequality, when you divide or multiply both sides by a negative number, you have to reverse the sign. So we're going to reverse this sign. So we get positive x is less than negative 8 over 3, which is a fraction. So let's look at what that graph looks like on a number line. And we're going to put negative 8/3, just kind of rough here. And because we don't have an equal sign in that inequality, because it's a strict inequality, we use a parentheses. Or you can use an open dot for the boundary point, but we're going to use a parentheses to follow our book. And since we want all the x's that are less than negative 8/3, that means all the numbers that are here with this left arrow. Now in interval notation, we would write negative infinity to negative 8/3 for this solution. Here we have another inequality. We're going to solve this one. Let's rewrite it down here. And I bet you can see that we're going to have to do some distributing. So to get rid of these parentheses, let's distribute the 3. And so we get 2 plus 6x plus 3 is less than or equal to 3x minus 4. And we combine the like terms, we get 5 plus 6x is less than or equal to 3x minus 4. And let's get those x's together. So we're going to subtract 3x from both sides. So we get 5 plus 3x is less than or equal to negative 4. Subtract 5 from both sides. So 3x is less than or equal to negative 9. And now we need to divide by 3. But it is a positive 3, so our inequality sign stays the way it is. And x is less than or equal to negative 3 is our solution. We're going to do a rough number line sketch here of this solution set. Find our boundary point, negative 3. We do have an equal sign, so this is going to be a bracket or a closed circle. And because we want the x's to be smaller than that negative 3, the arrow does go to the left again. So our interval notation is negative infinity to negative 3 with the bracket on negative 3, but infinity always gets a parenthesis, so no bracket for that. Okay, now we are going to make a scatter plot. Let's label the x and y coordinate axes and then just plot the points. Remember, our first coordinate is x and our second is y. So here are our 4 points. That should be review for you. All right, problem number 38 says complete the table for the equation 2x minus y equals 4. And I do want us to use our graphing calculator for this, just for practice. So we need to solve for y. We need to get that equation in slope-intercept form. So we're going to isolate the y on one side. So let's subtract 2x from both sides. Now these are not like terms on the right, so you're going to notice I'm going to write negative y, don't lose that negative sign. And then I'm going to switch these orders, so put the negative 2x plus 4. Now we don't want a negative y, so we need to change all the signs to make that y positive. So y equals, and here we have a 2x minus 4. Now let's go get our calculator. And we're going to use that upper left-hand corner button that says y equals. That's where we're going to input our equation. So the gray button, y equals, and then we're going to put 2x, don't forget there's an x key, minus 4. Then we're going to look at the table set, and since my table starts at -1, I'm going to just let my table in the calculator start at -2 and go by increments of 1. Now, second table gives you your table. Pretty cool, huh? So now we just input, we read off of the calculator the values that we need for our table. We fill in our table. Now the next problem wants us to determine the x and y-intercepts for the graph. And looking at the table, as you know, the y-intercept is the point where x is 0. And the x-intercept is the point where y is 0. So let's circle those two. We're going to use that to help us graph our line in the next problem. So let's draw in our y-intercept and our x-intercept that we use, and we're going to use those two intercepts to draw a line through the intercepts that gives us the graph of this equation. And if you want to just use your calculator, the graph key, then you can check your work. Notice that our graphs look the same. In our next problem, we want to determine whether the order pair -4, 1 is a solution to the equation y equals -3x minus 1. So we're going to substitute in for x and y and see if we get a true statement. And sure not looking like it's a true statement. 1 does not equal 11, so no. Nope, that order pair is not a solution to our equation. Now this one says, write the slope-intercept form for the line shown in the graph. And as you remember, slope-intercept form is y equals mx plus b. So we need the y-intercept, that's our b. We look at where the line crosses the y-axis. That happens at 0, 5. So b is 5. Then we're going to count using the graph squares to find the slope. So you pick two nice points. I'm going to use the y-intercept, and then I'm going to count 1, 2, 3, 1, 2, 3, 4 down and 2 over gives me a nice point on my graph. So my slope is -4 over 2, which reduces to -2. So this line has a slope of -2. And y equals mx plus b, so y equals -2x plus 5 is the slope-intercept form of the line. That's pretty cool. All right, now we're going to sketch a line passing through the point 4, -3, and having slope -3 over 2. So use that 4, -3 as your starting point. Graph that on your graph. And then it says slope is -3/2, so we're going to go down 3 and right 2. -3/2, down 3 and right 2. And then just join those 2 points, and that gives you your line. To write the equation of a vertical line passing through the point -2/3, 1/3, just got to remember that vertical lines have equations of the form x equals a number. There won't be a y variable in the equation. So we're looking for the x value, and the x value is -2/3. So x equals -2/3 is the equation of the line. All right, we're going to find the slope of a line when we're given 2 points, so we're going to use the slope formula. I'm going to go ahead and label my x1, y1 and my x2, y2. And so m is y2 minus y1, so subtract the y values, over x2 minus x1, so we're going to subtract the x values of these 2 points. And so in the numerator, we get a -7. Negative 4 minus 3 is negative 7. And I like that the bottom is 1/2 plus 1/2, which I know is 1. So our slope is negative 7. Find the slope-intercept form of a line with slope negative 4 and y-intercept negative 3. And so remember, that means that our m is negative 4 and our b is negative 3. So just substitute right into the slope-intercept form of a line, and we get y equals negative 4x minus 3. Okay, and our next problem, we're going to find the slope-intercept form of a line parallel to y equals negative 1 plus 3x and passing through the point 2/3 4. And if you remember that parallel lines have equal slopes, then just use the slope from the line that's given to be our m. So remember, the slope is the coefficient of x. So m equals 3, and then we're going to use x1, y1, the point that we're given, and we're going to substitute that into our point slope formula. And then we're going to get the equation in the correct form, in the slope-intercept form, which is what we want. So distribute this 3. Don't forget that 3 over 1 times 2/3 is just 2, negative 2, so that's kind of cool. The fractions go away. And then solve for y. When you solve for y, you get y equals 3x plus 2, and that's your slope-intercept form. This time the line is perpendicular. So we're given a line, and the slope of the line that's given is 2/3. And because we know that perpendicular lines have slopes that are opposite reciprocals of each other, we're going to take the opposite, which is going to make this line negative, the slope negative, and then flip the 2/3 to get the reciprocal. So the slope of our line is negative 3 over 2. And now we're going to use the point that's given and to put into the point slope form of a line, and then from there we can just solve for y. So distribute this negative 3/2, we get negative 3/2 x, and that's negative 3/2 times a positive 2. The 2's are going to cancel, so that's a negative 3. And now solve for y, and we get y equals negative 3/2 x. And that's our perpendicular line. Now we want to find the slope-intercept form of a line when we are given 2 points. So the first step is to compute the slope, again using the slope formula. So remember that the slope formula says subtract the y's. So we're going to subtract 0 minus 1 over, and then subtract the x's. Negative 3/2 minus a minus 2. And so on the top we get a negative 1. That's not a problem. But down here in the denominator we have to add these two fractions. So use your calculator, or here's a little review. This 2 is 2 over 1, and we're going to need a common denominator. So then the common denominator is 2. So we're going to change these two fractions to that common denominator. Changes that numerator to 4. And when we add 4 plus negative 3, we get 1/2. So now we have negative 1 over 1/2. And remember that with a fraction, that division bar, that bar there is a division sign. So we have negative 1 divided by 1/2. And let's flip and multiply. So we get a negative 2, and pardon me that I lost my negative sign there, I can see. So now we're going to use the first point, negative 2, 1, and substitute 2-point slope form. Don't forget that that slope should be negative. But now go ahead and solve for y. And distribute that 2, so we get a 4. So y equals, we got to add 1 to both sides. So you should get y equals negative 2x plus 5. Negative 2x plus 5, since there's a missing negative sign. Okay, last problem. Y minus 3 equals 1/2 x minus 8 let's rewrite in slope-intercept form. We've been doing this for several problems now, so it should be old hat. Distribute the 1/2. And so we have y minus 3 is equal to 1/2 x. And then 1/2 times the negative 8, you know the 1/2 of 8 is negative 4. Add the 3 to get the y by itself, because that'll be our slope-intercept form. So y equals 1/2 x minus 1.